At this stage, we have introduced most of the key processes in software engineering, regardless of whether you are primarily agile or waterfall based. So the last key process that we will cover here is maintenance. So let's start with a formal definition. And according to IEEE standards, this is the formal definition. So maintenance is the modification of software product after delivery to correct faults, improve performance or other attributes, or to adapt the product to a modified environment. With this definition, we can basically determine the constituents of maintenance, which can be seen in this side over here on the left side. All right, the first one being corrective maintenance, the second one is adaptive maintenance, and the third one that is included in this maintenance process is perfective maintenance. All right, so before we delve a bit deeper into these constituents of maintenance, let's establish the main reason why maintenance is important. All right, so we see this graph over here, or this pie chart over here, okay, where the percentages basically represent the cost as usual. All right, always, some of the priorities that we set are, often related to the cost or of what it takes to build this software. All right, and cost, as we know, is also related to the effort, as you guys have practiced effort estimation in the early parts of this module. All right, so whether cost or effort, I mean, they can be treated as synonymous right here. Okay, so we can see that this is a typical representation. Of course, the exact numbers over here is not the most important thing. Okay, but basically, this enables us to know that maintenance takes up the most amount of effort, and in turn, it is taking the most amount of cost in any software project. All right, so with this, I guess this would be an important aspect of software engineering that we should spend a lot more time in. So let's just go into each one of these types, or not types, okay? Each one of these components of maintenance. All right. So the first one is corrective, and as indicated already in the definition, one of the key things that you will do in maintenance operations is to correct errors. Okay. So and what sort of errors? I mean, it's basically resolving any sort of problems with your software, but because it is already like delivered, maintenance is this term that basically refers to after you deliver something, what continues to happen with your involvement with this software project. All right. So since it is already delivered, we can sort of assume that the errors that we are talking about is mainly consist of operational errors. Okay, which is why I wrote this over here. In general, it can be sort of be related if we think about programming itself. Not so much of compile time errors. Okay, I assume that those have already been addressed since we are in production. And when we talk about maintenance, all right, it's more about operational errors like logical error and runtime errors, as example over here. For example, this shows an average function on the left side over here, and you can see pretty much that due to whatever reason, carelessness, which happens to all of us during intense bouts of coding, that we forget about the bracket and will produce the wrong answer. So this, as we know, is known as a logical error. Okay, similarly here, this is not really a logical error, but it is still a form of runtime error. And in general, there's so many different types of runtime error. Like here, if you're not too familiar with JavaScript, you may think about JavaScript having the same kind of scope as normal, like general purpose programming languages, but in fact it has some of its nuances which easily trips some of us up like this over here. So this function, it's pretty common that in your website, right, you want to have when somebody clicks on a button, you would set a color. Sorry, not click on a button, but this button basically you would first set a certain color as the basic color. All right, but when you implement a button, definitely you would implement some sort of a callback function based on certain events, okay, like the click event. When you click, this code wants to set the color of this button, okay, as another color. All right, but the problem is that in Java, this scope is a bit of a different thing. So this is actually the wrong scope, okay. And we'll not delve into further details. Of course, you can go and Google what is wrong with this, and this will cause a runtime error because it cannot find the object that this is referring to that has the set color function. Okay, so other types of errors may be also like infinite loops or memory leaks. Okay, all these things are common runtime errors, which in the minor sense it may not crash but produce like a strange behavior, but like like lag, intense lags in your software. Okay, or it may just cause your software to crash. Okay, or run forever. Okay, so all these behaviors that really you want to avoid. Okay, so we need to correct all of these things, and in general, this is classed under corrective maintenance. Okay, the second portion of maintenance is called adaptive maintenance. Okay, and it is basically required because of the environment that your system or your software resides in. Okay, the environment that this production software definitely is dynamic, right? So conforming to this environment changes. Environment, as we know, is in our real human environment. It changes every single second, right? Okay, so this is a core part of things that we whether as humans or whether we are coding, we need to adapt to. Okay, so that's why this is known as adaptive maintenance. Okay, so the examples here, one of the things that wrote over here is that you are trying to maintain the code without changing basic functionality, because here we're in maintenance phase, and what we want to do is that we want this at least for this type of maintenance, is that actually we are not trying to change functionality or anything. It's just that we want to maintain the same functionality to work when our environment changes. Like for example, the most common change that we will encounter is the operating system. Okay, because most software relies on some form of operating system to run the software. Okay, like in this case, if iOS comes up with a new version, it's pretty common that your app may not function in the way that you have expected. Okay, it is the cause of most curse words, right, against the big tech companies. Other changes other than software, okay, the OS that your app resides on, which constantly updates, because the OS, the big tech companies that runs the OS on the devices that they come up with, they always want to improve as well. Okay, so we need to go along with that. Um, Other than software, hardware is also something that pretty common will change. The example here is just in terms of a VR example, that for example, new versions of the VR controllers that your app resides on, like the Oculus Quest. Next version, the controller has a new functionality or has a changed functionality, then you're sort of obliged to support, right? Even if it is some new thing that doesn't really affect you, but the fact that it comes up with a new controller, and you need to change your code to conform to the way it works, you would sort of need to do that. Otherwise you will lose like users who are on the new controllers. Yeah. And other examples might be just, the fact that the new flagship phones are being introduced, whether with or without the notch on top, um, all these things, that you need to conform to whenever the hardware changes. Okay, so these things are known as adaptive maintenance. All right, the third part here, actually there's a fourth part, okay, but this preventive maintenance is sort of subsumed into perfective maintenance. IEEE used to have this, but as years go by, well, the recent definition doesn't really explicitly mention preventive maintenance. Although when you read online, some texts still stick to this word to differentiate, the types of maintenance that you do that prevent problems before they occur, versus other types of perfective maintenance that you try to improve the system's functional and non-functional qualities. Okay, although this preventive maintenance operations that you do may also be classed under this definition. Okay, just a minor distinction over there, whether you want to have this distinction or you need to understand this distinction is up to you. Okay, so this perfective maintenance is actually huge, okay, because it encompasses all improvements that you can do to your app or system. Okay, as the name implies, you're trying to perfect your code to improve the system's functional as well as non-functional qualities. For perfective maintenance of functional qualities, it is pretty straightforward to understand because it is basically adding use cases and working on them. So this is called functional, perfective maintenance. Okay, like for example, its running version, during the maintenance phase, your company or your team, if this is an app that belongs to that is your company's product, you decide that okay, this new feature would really be add to the usefulness of whatever your offering is in this app. So you need to add this and work on it during the maintenance phase. So this is functional quality, perfective maintenance. For non-functional quality, well, it is a huge rabbit hole, as you can see in this long list of different things. Sorry, there's missing one line here. Okay, long list of different things that can be a type of non-functional quality. Okay, which includes the usual suspects of software quality, right? As we know in non-functional requirements. Okay, like for example, usability. In general, improving usability of various aspects of your app is a constant endeavor. And this example of a VR interface may be a bit more extreme, okay, as it is a big open research problem with no clear guidance. So you need to constantly, iterate, create different types of interfaces, curved, flat, and so on, 3D interface, and then test on users and then improve this usability aspect of this type of interfaces. And for performance, right, similarly, this is like a constant pursuit of better speed and lower memory. Okay, like in this case, improving the sorting algorithm in your code. Right, other examples, robustness is basically trying to improve the stability of your system by enhancing its ability to handle special or stressful situations, like this example over here, increasing our backend database drives size, okay, so that our uploader interface will not stall, right, in the user space when there is an abnormally large number of concurrent users who are trying to upload in the system. Okay, so this actually improves the stability to handle special situations like that. Okay, so that is robustness. Other common terms of software quality are also exampled over here. Like reliability basically refers to like preventing crashes by catering to more types of situations that you expect, like adding this uh, extra check over here would allow you to prevent your app from, exhibiting bad behavior by, catering to more types of situations, okay, making it more reliable. And security, this is just a extremely trivial example of improving security by adding a preventive check against possibly malicious files. All right. Then we have this um, last part over here, which is maintainability. Okay, or last type of non-functional quality that you may want to do in your maintenance phase. And as this word implies, okay, maintainability, maintenance, okay, it matches maintenance pretty well, which is why this aspect is, the largest rabbit hole. Okay. Um, and what does this mean? I guess most of you have come across this word, when you're trying to establish, good coding practices. In your code review, for example, maintainability is a big, goal that a code reviewer tries to establish. Okay, um, sometimes it may be often like overlooked, this non-functional quality called maintainability because it's just so broad, sometimes a bit subjective. It depends a lot on your team's practices and so on. But there are many general good practices that all teams, would want to look at and possibly customize for your own applications. All right, it may not look like having better code. It may not look like it directly enhances your product quality, but it actually does, and in a big way. All right, if your code is more maintainable, it means that more people can work on the same piece of code more easily. And we know that the key to good software is the ability to iterate well in development and slowly grind, our way to, good quality software, which is also why Agile has dominated most software projects where it fits, of course, and where the stakeholders have the power to make this decision for Agile processes to work. Okay, so with that being said, let's look at what are the common things that we do in when we look at maintainability as part of non-functional quality that we want to improve during the maintenance phase. Okay, you can see that there's this matching two sites that we have over here in terms of having code smells on one side, on the left side, as well as refactoring patterns on the right side. So what is this? This is basically, as a software engineering, as a field, it matures. Naturally, people have documented the common pitfalls of code, normally commonly known as code smells, okay, and consequently the common recipes, that we are able to use to resolve them, and this is commonly known as refactoring. And here we are looking at refactoring patterns, okay, very similar to your design pattern kind of a concept. All right, so let's look at several examples over here. Here, this code over here, sorry, let me circle the right code here. So the code over here exhibits, two code smells. The first one is a long method code smell, and the second one is, the comments code smell in general, but it is more aptly named as bad comments, if we want to be more explicit about it. All right, so long method, as the name implies, it means that your method is too long lah. All right, long, is not so much of the length, but there's too many different components, different responsibilities of in one single method. Okay, and at the same time, because it is so long, the coder probably needed to categorize this one single method into many different subparts. Once we see that, this is like quite a red flag lah, and it smells bad. Okay, in the same terminology that this refactoring uses. Okay, so once you see this, wow, you need so many comments, section your stuff, it means that, yeah, you are trying to do too many things in one long method. And naturally, the refactoring pattern is pretty obvious. To extract each one of these subtasks into its own, sorry, these two init, maybe I'll just use something permanent. Okay, so these two init functions into here, the decompose section into here, looping here, and combining the subparts here. All right. So that would make your code, much more maintainable. Okay. Um, Both in terms of the subcomponents, more understandable subparts, and when you change a subpart, there's no need to change one whole big function itself. Okay. And for comments, generally we also do not want developers to spam like inline comments or write long paragraphs inside the methods itself. Okay, the internals of the method should be pretty clean of comments and should ideally be self-documenting. I believe most of you know what that means, having your variable names, nicely worded with camel case or with underscores, whatever your practice is, or whatever the code's common practice is, the language's common practices. All right. Um, and if you need a lot of sectioning and explaining, I think probably it already smells of something fishy. Okay. Yeah, and speaking of comments, generally, yeah, the main thing that we are looking for is the code headers. All right. So your, sorry, not code headers, but your function headers should be nicely documented. The entire function, should be able to be explained in a paragraph on top, with the proper inputs, input arguments, whatever. Okay, one, and some explanation as well as the return arguments um, properly explained as well. Okay, so another coder or yourself after a year, okay, when you look back at this function, you should be able to easily make out what this function does without looking deep into what is in here. Just by reading what is here, you should be able to make it out. And having such a big function, it's very difficult for you to have a simple concise paragraph like that. But once you have things separated into its constituents with very concise responsibilities, then you would have a easier time making this section. All right. So this is one example of a code smell, and the refactoring pattern to deal with this is called extract method. And in fact, in a lot of IDEs, you would already find this feature inside there, that you can just select a certain section. You can just like select this and then choose the extract method. Okay, choose some extract method from your drop down menu. Okay, and then you would be able to extract a function. Yep. So refactoring the tools are already available, widely available, because these are some common things that we do in maintenance. Okay, so the second example over here is has an interesting name, inappropriate intimacy. All right, so this is basically smelling of two classes being overly intimate. Okay, when they don't need to. Okay, in real life we don't really interfere lah, right, with matters of the heart. Okay, for other people that are maybe not within our family or whatever. Okay, but this is in our own code. Okay, so we have to fix this inappropriate intimacy over here. All right, so what is happening here is that the vampire class, okay, only uses the human class to talk. Okay, I mean, it seems to always need this particular talk method. Okay, but the relationship is just users. All right, so it's a closer relationship than stipulated in the relationship of the code lah. Since it's so highly tied to this, it needs the function in order for a vampire to talk. Okay, so therefore, the relationship should be closer. So once we apply the refactoring pattern to fix this inappropriate intimacy smell, okay, and the name of the pattern that should be applied is called replace delegation with inheritance, okay, because this is like delegating and this is inheritance. All right, so there is a more intimate relationship there, so therefore we need to marry them, okay, by converting that relationship into something that is stronger. Okay, so really a vampire is a type of human, okay, so that you can directly use the talk method over here. Okay, so the last example is an even more funkier name. Okay, at first when I first saw this name, I really have no idea. Okay, until I look at the illustration and look at examples of what this actually means. Okay, similarly, it is as trying to indicate that this code smells of a wrong relationship. Okay, in a way, it's sort of the reverse kind of a problem that this is establishing a inheritance relationship. Okay, where the duck, okay, is inheriting qualities from the human. That means we are saying that duck is a type of human. Already that concept sounds wrong, right? But let's say we implement the duck class and realize that the duck also we are implementing the walk code of the duck in the same manner. So why not we just inherit from the same code, the method here in human, to allow for the duck to walk. Let's say it's a pixelated like old school type of game. That walk really just means you change the position from this to that, okay, and activate the animation of the walk sprite for duck and walk sprite for human. So it's the same code. So why not we just inherit it? But it's wrong, okay, because what you're doing here is that you're trying to use inheritance as a code combiner lah. In essence, you are along the right line of trying to reduce duplication of code, and trying to just make your architecture or your code pattern a bit nicer. Okay, but this is the wrong way because firstly, a duck is really not a human. Yeah, and when the concept is different, most likely in the human you already would have other functions that are not cannot be done by the duck or are different from the duck. Like for example, just now that talk, okay, or maybe I'll just draw it in here, okay, since it is part of the human. Okay, so this talk method of the human, most likely it would be different from the duck, or rather, let's say, okay, in this example, human has a talk function, and the duck has another talk, or there's no talk lah. The duck has only can quack, right? And it's entirely different. Okay, let's say the implementation is entirely different. So here already there's a conflict lah. So therefore, we should change the relationship. Okay, and since we know that walk is the same code. Okay, so therefore we can sort of extract this walk method into another type of a class, called the behavior class, or walk behavior class to be specific here. Okay, which can be composed, or contained inside both the human and the duck, right, using a composition relationship. Okay, so this, in the reverse way, we are trying to replace replace inheritance with delegation. All right, so these are all examples that you can find from many popular websites. You can find a lot more code smells from websites like SourceMaking or Refactoring .guru. Just like how design patterns help you figure out the right code structures before you code, right? Refactoring patterns actually help you figure out the right code structures post implementation. Okay, so after you code, that's why it's the maintenance phase, right? So before the maintenance phase, the design phase, for example, design patterns help you understand what you need to do before you code, or guide you along the right way before you code or during when you code. But after you have the code, what we need to do is to use this refactoring patterns and code with respect to the code smell that you sift out, or you sniff out, okay, to do it to improve your code. All right. Um, so of course nobody can remember every single code smell that is popular or every single refactoring pattern. That is why there are these websites. I mean, people have created these websites, and that is why they are so popular. Okay, so certainly go to look at the websites. Have browse through the refactoring patterns or the classes of different types of refactoring patterns and code smells, and then to get a good sense of what is out there. Okay, and then when the time comes, okay, when you need to make your code better, okay, certainly you would have a better idea how to go about it. All right, that's the end. I will see you in class.